Welcome back to SaaS Startup Academy. In today's episode, Episode 8, we're diving into a topic at the heart of ethical AI, fairness and transparency in AI models. We'll break down what it means to build fair, unbiased AI systems, explore the techniques for reducing bias, and discuss how to make AI decisions more transparent and understandable for everyone. As AI systems become more deeply integrated into society, ensuring fairness and transparency isn't just a nice-to-have, it's a must. Let's explore how to reduce bias, build interpretable AI, and foster user trust in these powerful technologies. And, if you haven't already, please like, subscribe, and turn on notifications so you don't miss future episodes in this series on AI and SaaS development. 1. Understanding fairness and transparency in AI models. Fairness and transparency are two key components of responsible AI. Fairness is about ensuring that AI systems treat all users and groups equitably, without reinforcing biases or discrimination. Meanwhile, transparency refers to the openness with which an AI system's decision-making processes are disclosed and explained. As AI has permeated various sectors like healthcare, finance, hiring, and criminal justice, the need for fairness has grown exponentially. Imagine an AI system used in hiring that favors one demographic over another, or a healthcare algorithm that provides unequal treatment based on race. These biases not only harm individuals but also damage public trust in AI technologies. Transparency, on the other hand, empowers users to understand why certain decisions were made. This is crucial because people are more likely to trust a system when they can understand its workings, even at a basic level. Transparency helps organizations not only to comply with regulations but also to demonstrate ethical commitment to fair and open AI practices. 2. Techniques for reducing bias in machine learning models. Achieving fairness in AI models starts with addressing bias at multiple levels. Bias in AI can stem from data, algorithms, or even the ways in which models are tested. Let's walk through some of the most effective techniques for reducing bias. A. Improving data diversity and representativeness. One of the biggest contributors to bias in AI models is biased or unrepresentative data. If the dataset used to train a model lacks diversity, the resulting model may be unfair or even discriminatory. For example, an AI model trained on images primarily featuring one demographic group may not perform as accurately on other groups. Ensuring data diversity is key to minimizing this kind of bias. Diverse datasets reflect a wider variety of experiences and characteristics, leading to more balanced and accurate models. Techniques to improve data diversity include collecting data from a broad range of sources to capture various demographic groups, backgrounds, and perspectives. Sampling techniques that ensure minority groups are adequately represented in the training data. Synthetic data generation to artificially create data that balances demographic representation, especially useful in cases where real-world data is limited. B. Preprocessing techniques to reduce bias. Once the data is collected, preprocessing methods can be used to further reduce biases. Here are a few popular techniques. Reweighting assigns different weights to samples within the dataset to counter imbalances. For instance, if there are more samples from one demographic, they can be given lower weights, while samples from underrepresented groups receive higher weights. Resampling. This technique involves either oversampling the minority group or undersampling the majority group to balance the dataset. Bias mitigation algorithms. Some algorithms like adversarial debiasing work by identifying and adjusting features in the data that contribute to biased outcomes. C. Algorithmic approaches for fairness. Bias doesn't just stem from data, the algorithms themselves can introduce or reinforce bias. Several algorithmic techniques are designed to improve fairness. Fair representation learning. This technique focuses on creating representations of the data that are fair and do not include biased information. Constraint-based algorithms. Algorithms can be trained with fairness constraints, such as requiring equal treatment across demographics. These constraints can be set during training to prioritize fairness alongside accuracy. Post-processing bias mitigation. This technique applies fairness adjustments after model training. For example, equalized odds involves making model adjustments to ensure equal performance across groups. The combination of these techniques enables a more balanced and equitable AI system, addressing potential biases at various stages of the model's lifecycle. 3. Ensuring transparency in AI decisions. Transparency in AI isn't just about sharing information, it's about making that information understandable and actionable for users. Here are some of the leading methods for ensuring transparency in AI models. A. Open documentation and clear communication. For AI to be transparent, users must have access to open documentation that explains how the model works, including the datasets, algorithms, and decision-making processes involved. Many companies now practice model cards, which are documents detailing the purpose, data, limitations, and fairness assessments of a model. This transparency helps users understand what the model can and cannot do and builds trust. Clear communication is also vital. For example, if a model is used in hiring, a simple description of how resumes are screened, what qualities are prioritized, and how fairness is maintained can help candidates trust the system. B. Interactive explanation interfaces. Some organizations have developed interactive interfaces to explain AI decisions. In finance, for instance, customers denied a loan might receive an interactive explanation showing which factors led to the decision. This approach enables users to understand specific factors impacting their results and even take steps to improve their outcomes. C. Algorithmic transparency techniques. Certain technical techniques also help improve transparency, such as LIME, local interpretable model agnostic explanations. LIME works by creating an interpretable model around a particular prediction, explaining why the model made a specific decision in a way that humans can understand. SHAP, Shapley additive explanations. SHAP explains individual predictions by breaking them down into the contributions of each feature. For example, if a model predicts loan approval, SHAP can explain how each feature, like income or credit score, impacted the decision. Fairness constraints. In some cases, fairness constraints can be incorporated into algorithms to ensure they treat certain demographic groups fairly, further supporting transparency in model outcomes. 4. Interpretable AI. Building explainable AI models. Another aspect of transparency in AI is interpretability. Interpretable or explainable AI models provide insights into how they make decisions, allowing users to understand and trust the model's reasoning. Here are some leading approaches to building interpretable AI models. A. Rule-based models. Rule-based models use a series of if-then rules to make decisions, offering a high level of interpretability. For example, a rule-based loan approval model might state, if income greater than X and credit score greater than Y, then approve. These clear rules make it easy for users to understand how decisions are made. Rule-based models may not be as complex or powerful as deep learning, but they are often useful when transparency is more important than predictive accuracy. B. Decision trees. Decision trees are graphical representations of decision processes that are easy to follow. In a decision tree, each branch represents a choice, and each leaf represents an outcome. Because decision trees are visual and straightforward, they are commonly used in settings where transparency is essential, such as healthcare diagnostics or risk assessments. C. Hybrid models. For balancing complexity and interpretability. Some organizations use hybrid models that balance interpretability with complexity. For example, a model might use complex techniques like neural networks but rely on simpler interpretable methods, like rule-based logic, for specific high-risk decisions. Hybrid models offer flexibility, allowing for robust AI while retaining interpretability where needed. D. Using explainable AI in real-world scenarios. Interpretable AI is already being applied in the real world across various sectors. Healthcare. Doctors can review interpretable AI models that show how factors like age, lifestyle, and medical history affect diagnosis and treatment options. Finance. Explainable models help banks clarify credit decisions, allowing applicants to understand why they may have been denied and what factors to improve. Human resources. AI models used for hiring can incorporate interpretability to ensure applicants understand the factors affecting their interview and job offer outcomes. Each of these scenarios demonstrates how explainable AI can enhance transparency, helping to build trust in AI-driven decisions. 5. The future of fair and transparent AI. Looking ahead, the future of AI will likely focus heavily on advancing fairness and transparency. With growing demand for explainable AI in government, education, and consumer sectors, more organizations are prioritizing ethical and accountable AI. To stay ahead of regulatory requirements, organizations should invest in transparency and fairness techniques now. Governments around the world are enacting new AI regulations, such as the EU's AI Act, which emphasizes transparency and accountability in AI. Companies that fail to adopt fair and transparent AI practices risk falling behind both ethically and legally. Building fair and transparent AI models is no longer just about avoiding bias or complying with laws. It's about leading responsibly in an era where technology is changing lives and communities. Responsible AI fosters user trust, enhances reputations, and leads to better, more ethical AI systems overall. 6. Conclusion. Creating ethical AI through fairness and transparency. To wrap up, fairness and transparency are the cornerstones of responsible AI. By reducing bias, ensuring transparency in AI decisions, and building interpretable AI models, organizations can create systems that empower rather than exclude. Thank you for watching Episode 8 in our SaaS Startup Academy series. We hope this guide on creating fair, transparent AI has inspired you to build ethical, trustworthy models that enhance user trust. Before you go, don't forget to like, subscribe, and turn on notifications for the latest updates on AI, SaaS, and technology trends. Let's build a fairer, more transparent AI future together.